right, so remember last week we started looking at probability distributions, and more specifically Friday we were looking at the binomial. So binomial is when we have two options. It's basically a yes or no. If there's more than two options, it's not binomial. And a fixed number of trials that are independent of each other. And then we can calculate the probabilities either by using the binomial formula, the n choose x, p to the x, 1 minus p to the n minus x. You guys remember seeing that? Or, if they're nice ones, we can use the table. So you might want to grab out your formula sheet to use the table. So since we had the weekend in there, I'll probably do this one both ways, showing you and just making sure we remember. Because the table is limiting, it only has n up through 15, or what does it go? It goes up to 10, 12, and then it does 15 and 20. And then it only has certain probabilities. So if we have a different n value or a different probability, we can't use the table, we have to do it by hand. So this one, 65% of adult Americans are in favor of the death penalty for individuals convicted of murder. In a random sample of 15 adult Americans, what is the probability that exactly 10 favor the death penalty? So, is this binomial? Do we have two outcomes? They favor it or they don't. A fixed number of trials? Yes, because we're looking at 15. So in this, my n, my number of individuals is 15. P, the probability that they say are a yes, in this case, would be 0.65. So on A, what's this 10? What variable is that? That's saying x is 10. So let's do it from the table and then we'll work it out by hand just to confirm. So you would go to your n equals 15, so that's the back page. Thank you. Our p is 0.65, and then we want to go down when x is 10, and we should get 0.2123. Does everybody see that on their table? If we did it by hand, remember the n choose x, p to the x, 1 minus p to the n minus x. So that's basically saying 10 said yes and 5 said no. And so do this on your calculator, make sure you remember how. Remember we did a parenthesis, we had to do the 15, and then you go to math over to probability, NCR, 15 choose 10. And we should get the exact same thing. Did we get that to work?
I don't see it on the table.
Oh, okay.
I might be looking at the wrong one, but I don't know. Am I not?
There's 2 pages of the table. And it's 15.
Oh my gosh. That's why I was doing the wrong picture.
You're welcome. Any others? Really, I'm freezing.
Really?
Like, I was just about to walk over and turn up the heat because
I think it's my new boots.
All right. So B, the probability that no more than 6. So what could x be?
0 to 6.
So you can calculate every one of those by hand and add them together, or more easily, we go to our table and we're going to add them all. So grab your calculator, go to the 0.65. So you'll notice at the x equals 0, it has 0.0000 plus. That basically means it's a positive number. The first 4 digits are all zeros. So it's small enough, it's really not going to make a difference. So the first couple are that. Then we add in the 2, 3, 4, 5, and 6. And I got 0.0423. Everybody get that one to work out?
Oh, I did that.
Let's look at what. Alright, remember we did also draw some graphs on these. This one doesn't specify the type of graph, so we're just going to make a very simple one. So if I want to graph the probability distribution, so that's essentially all the probabilities, with n equal to 8 and p equal to 0.15. So that way we can describe the shape of it. So if we look at this, so my x's are down here, we have 0, has to go all the way up to 8. And my probabilities are on the axis. Let's look at our table. If n equals 8 and p equals 0.15, so that is on the table. Those are the probabilities that we are going to be graphing. Alright, so it has at 0, 0.2725. The probability is 0.38. 2, 0.23. 3.08, 4.0185, so that's very small. 5.002, 6, sorry, 5 was 0.0026, 0.002. All of these are just extremely small. So could you describe the shape of this to me? Right. It kind of peaks right here and then it just keeps extending on to this side. Do we need another one of these? Okay, we can handle that. So as we go on, it will be really important for a lot of the things that we're doing it to have bell-shaped data. So we're seeing right here, this one is obviously not bell-shaped. So the question is, when is it going to be bell-shaped? So our general rule of thumb that we will see a lot in the coming chapters, if n times p times 1 minus p is bigger than 10, then it becomes more bell-shaped. So in those cases, we'll be able to assume that it'll become bell-shaped because the empirical rule would start to apply there. Remember, empirical rule tells you 68% of the data is within 1 standard deviation. Within 2 standard deviations, it's 95%, 99.7 within 3. So it becomes more and more bell-shaped. Anything outside of that 2 standard deviations, remember 95% is within 2 standard deviations, so that leaves 5% for the tails. Anything with a probability of less than 5% is considered what? Unusual. And so we will have that still coming into play. So last question. 35% of all car-owning households have 3 or more cars. A researcher believes the percentage is higher. He conducts a simple random sample of 400 car-owning households and found that 162 had 3 or more cars. Is that unusual? Okay. So, how could I decide if this were unusual or not? Okay. How would that help me?
You could plug it into the mean minus 2 standard deviation
Okay.
plus 2.
So we know that anything not within 2 standard deviations is considered unusual. So the 2 options, we could try to just put this into our calculator. However, it's such big numbers. If you actually try to put this in and ask your calculator to find this for you, to find a probability, it says error overflow. It basically freezes that calculator and it can't find it. So it becomes a little more challenging because the numbers are so big it's dealing with. But we know bell-shaped data, anything within 2 standard deviations would be fine, right? We expect 95% of the data to be within 2 standard deviations. So let's check what those thresholds are. So we need the mean. So this is binomial. Either they have the 3 or more cars or they don't. So to find the mean of a binomial, look at your formula sheet. What's the mean of a binomial?
Sum of x times p x.
That's just a regular probability distribution, which we could do. But if we could look, there's a more specific formula for the binomial. No, we could do that if we made the whole distribution. Or we can just do n times p if it's binomial. So we know there are 400, p is 0.35. So we get a mean of 140. Standard deviation of a binomial. Look at your formula sheet. What does it give us?
Square root of np times q.
Yeah, n times p times 1 minus p or q. So 400 times 0.35 times 0.65. And we get standard deviation 9.54. So we need to know what window is acceptable. And acceptable would be anything within 2 standard deviations. So the mean minus 2 standard deviations. 20.92 mean plus 2 standard deviations. Gives us 159.0. So this is normal if you're somewhere in this range. So would 162 be abnormal? Yes. Questions there? Okay. You guys want time to work on that homework assignment from Friday? Do we need to do any more review stuff? Are we okay?